Starting the recording. Cool. So yeah, Charlie, it's awesome to have you today.
Yeah,
Um,
thanks for
as I
having
was
me.
just yeah, as I was just saying, we are the University of Dayton Game Development Club. We're all undergraduate students at the University of Dayton in Southern Ohio, and myself and Justin founded this club last semester to get students together to work on game jams and like graphics programming and stuff like that. And since then, we've worked on a game jam together, which is really fun as a group to compete. And then this semester, we've been working on creating a fighting game in Unity and an arcade cabinet to put the fighting game on. So we're gonna put an arcade cabinet made from scratch in our student
Oh,
union, and kind of like spread the word about the club
yeah,
in
yeah.
that way.
Oh,
But
sweet.
I just, do you think you would be able to like give like a brief introduction about
Yeah,
yourself to
totally.
everybody?
Yes, my name's Charlie Callahan. I guess my background's probably a little bit different than like the average game developer. I went to undergrad for mechanical engineering actually. And then I ended up going to grad school also for mechanical engineering, but kind of focused on like optics and like basically working on these like laser gas sensors. Um, and that work was kind of like it seemingly, I guess how it relates back to mechanical engineering was like we were using the gas sensors to measure like engines and stuff like that. But it was mostly like optical engineering and actually quite a bit of like computer science, because in order to like get these things to run, you need to be able to process like a huge amount of data in a short period of time. And so to do that, we were using like FPGAs and basically like kind of like faster CPU algorithms. That's kind of like what my PhD is based on. But yeah, then as I was kind of in grad school, I just started working on my own on like, building this game engine and game, which is, the purpose of the engine, I guess. And yeah, I had, just been working on it for probably like 4 or 5 years. And I just started posting stuff on like, X or Twitter. But yeah, it's been a work in progress for a while. Ultimately, I want to like release that game. And I don't know. Yeah, just kind of do two things. But that's kind of, I just kind of got into game development on my own accord there. uh,
Yeah.
Coming from like a pretty unrelated field.
Yeah. I guess like one thing that I was curious about is because when I looked at your profile, obviously you stand out as having like a mechanical engineering background, PhD in mechanical engineering, but then you're doing all this cool stuff with graphics programming.
Yeah,
So I was
yeah.
kind of curious, like, when did you get into programming? Because I know that you said obviously it's really important for working with FPGAs and doing processing on like laser signals and stuff like that. And actually, I think Dan and I know a lot about the crossover because the research groups that we work with have like teams that span the like everything. So like a
Oh yeah.
harmonics team that is also made up of computer scientists to do
Mhm.
signal analysis and stuff like
Yeah,
that.
yeah.
Um, so did you get into programming through the mechanical engineering work or was it before?
Yeah, pretty much. Like so in at CU Boulder where I went to undergrad and also grad school, basically we did this like senior design project where at the like senior year you a bunch of like companies will sponsor projects through the university and then the students will work on them. And that's also how I got into like the laser stuff was we built like a laser temperature sensor. And that's kind of like just in order to like complete that project, I basically needed to learn how to program a little bit. Um, and incidentally, I also met like so I'm working on this game engine with one other person who's one of my buddies that I met in that project. Actually, we realized that we work well together. Um, and so yeah, that's kind of where I got into interested in like programming. And another thing is like kind of when I was in, when I was in like high school, I really liked to build stuff like in my garage. Like I would build, like I had like a little lathe and stuff, and I would machine metal parts and built like a little jet engine when I was in high school. And then, but then when I got to college, like I didn't have access to those machines and stuff. But the thing I really liked about programming is that you can basically build stuff without any equipment. Like all you need is a laptop and you can do it anywhere. Um, so I think like when I was in undergrad and then starting grad school was kind of what it really drew me to programming was the ability to like build and build stuff from like my dorm room or something, or where I don't have access to like a little machine shop in my garage.
Yeah.
So that was kind of a big thing, I thought. And then yeah, just like going from that project, we wrote a lot of the code in like C++, which I thought was cool. And I was always interested in like how games worked. Like when I was younger, I was like, I just like had no idea how they were able to make a game. Like I was like, this seems like magic, like playing like Grand Theft Auto or something. I was like, this must be the most complicated thing that's ever been created. And so I wanted to figure out how that worked. So then I kind of just started. I started with like that OpenGL tutorial, like learnopengl.com,
Yeah.
and then got like the first triangle on the screen kind of thing. And then, yeah, I just kept going further and further and then ended up like restarting a few times to finally get to like a better architecture for the game engine and everything. Um, but yeah, I mean, I would say, yeah, definitely started programming. You know, I got introduced to it in school. So, um, yeah,
Yeah. I have a bunch of questions, but I will say, like everybody else in the call, feel free to jump in
yeah,
whenever.
yeah. Totally.
But one thing that you were talking about that kind of reminded me of myself actually is like getting into more like um physically grounded stuff, like creating things on your own, like in high
Yeah,
school. Like
yeah.
I was the same way.
Uh,
I had like obviously I had like two 3D printers, like
mhm.
a really crappy Chinese mill that you could
Yep.
buy on like Alibaba and like put it together. Um, and then I
Uh-huh.
kind of went to college and I started to appreciate programming more because I was like, well, I can't bring all this stuff to my dorm
Right.
room. Like I can, and then I was like, oh, I could just make anything on a computer, you
Mhm.
know. So I think we're
Yeah,
similar in that way.
I know.
And yeah,
Sorry, go ahead.
I was just gonna say that's always one of the things that I thought is most interesting about programming is that it's like you have so much creative expression.
Right. And like the other thing that's cool about programming that's different than like, kind of machining stuff in your garage that just like by default you could make like the most advanced thing anybody could make on a computer, just on like a laptop versus like if you were trying to machine like some crazy thing, you can't just buy like a 5-axis milling machine or something for like, it costs a ton of money and stuff. But you can pretty much make like the most cutting edge technology without any hardware, any
Yeah.
complicated, expensive stuff.
Do you know the YouTuber? I think his name is like Stuff Made Here. I like watching that guy because he has
Oh,
like basically accumulated like hundreds of thousands of dollars worth of industrial machinery in a basement, and he has like 5-axis mill, like
uh, oh, that's pretty sick. Yeah, I'm not familiar with that guy. I used to watch like This Old Tony and stuff like that. I don't know if you
yeah,
know him, but I would, yeah, I aspire maybe one day I'll be able to get a 5-axis milling machine. This
that's the
game,
dream, right?
yeah, yeah.
Yeah. As far as like the graphics programming stuff, I'm kind of curious. So when I was thinking of questions to ask you, I noticed you tweeted like a while ago, you said having a background in optics slash optical engineering helps a lot with graphics programming.
Uh-huh.
Could you kind of explain what you meant by that and why
Yeah,
your
yeah.
background has been important?
I mean, it helps. So, like, I'd say there's like two reasons. Well, the main reason it helps mostly is just like understanding how light interacts with things. Like, what's the physics, like, what actually happens, or like if you're trying to simulate light, like coming in from all, or like coming out of your computer screen to look like you were looking into a 3D world. Like, what's the physical, like, what's the mathematical way you would model that? And like, what's the physics behind it? And that helps a lot when you're doing, I think, graphics programming because it just gives you like an understanding like of what it should be doing, even though like the algorithms that run on your GPU are completely different than like physical reality, unless you're doing like ray tracing maybe. Um, but yeah, primarily, I mean, a lot of it is you don't need to know to figure it out, but there's stuff like that I've used, like I don't know, like refraction, like Snell's law and Beer's law absorption, stuff like that. Just like understanding how like PBR materials and like roughness, like scattering, how all that works, and it kind of helps you to like look at it and be like, oh no, this looks wrong because of X, Y, and Z. which is one of the hard things about graphics programming is it's hard to like debug and like if something's subtly off, it's really hard to figure out. Versus with
Yeah.
like, regular programming, you can be like, all right, it's supposed to do this, it's supposed to do X, Y, and Z. And like, oh, it's not doing this correctly. But with graphics, you're like, oh, the image just looks off and it's hard to figure out why. But having a background and like just like knowing how light is supposed to work, that helps a bit with just in general, I'd say graphics programming.
Yeah. So you mentioned PBR, which for those in the call who are not aware is physically based rendering. Would you be able to just explain so that everybody's on the same page,
Mhm.
like what is physically based rendering? How does rendering actually work?
Yeah. Yeah. So like, um, well, okay, I guess to start with like how does rendering actually work? Basically what you're trying to do is simulate like a 3D scene in your computer screen and have the pixels on your screen emit light that looks like what it would look like if you were looking at something in real life. And do that in like a computationally efficient way. And the way that that works is like you send the GPU a list of triangles basically, and then you kind of transform those triangles into the space of like your screen, so that it looks like it's in 3D space or 2D space in some cases if you're doing like a 2D game. But then you also have to figure out like how to calculate like how the light looks after interacting with each of the triangles on the screen, like each of the solid objects. And so like PBR is, physically based rendering. It's basically just a way of calculating the lighting. I don't know what the exact definition of PBR is, but I think it's more like how you set up the materials and the lighting to look like physically based so it looks realistic. Um, and the way that it works is, each of these triangles, you add like a few extra textures or like images that you map to the triangle. So like you might have a base color, which is like, kind of represents what colors the material will reflect versus absorb. So like if you had a red piece of plastic, the base color would be like red or something. And then you also have like a normal map, which allows you to add little details of like how the material is like textured, I don't know, like if it's shy or if it has like bumps on it or something like that. And then also like the light interacts with the material will depend on whether it's like a metal or a dielectric. And so you also have a image that says like this part is metal, this part's not. Um, and like roughness, which is the other one. So like a shiny object's going to look different than a rough object. And so you have this other like roughness map, which says, this area, the material is rougher than this area. And so the light should be reflected at a more like a delta function or something instead of like a broad distribution of light angles being reflected. I guess that maybe that is a little too in depth of a description, but that's pretty much how it works, I would say. Yeah, I don't
Yeah.
know.
I mean, I think that was a good description.
Yeah.
How so a lot of people throw around like ray tracing, which is
Mhm.
a very different way of doing rendering and lighting. How does that differ from something like PBR?
Yeah, so like ray tracing is like basically what you're doing is you're basically take your ray tracing is a more accurate way to simulate light where you're saying like, okay, imagine you have a light bulb and you could say it's emitting a bunch of like light rays, which is a way of approximating like a wave mechanics of light. You can say it's a ray. And then you can say like, oh, this ray hit a thing and reflected off, and then it hit another thing and reflected off, and then like some of those rays will hit your camera, and then you can build up the image by casting a bunch of rays and reflecting them off of all the objects in the scene. And so that like usually looks really good, but it's too computationally expensive to do. Usually, I mean, maybe some games do it, um, but it's pretty computationally expensive to like send out all those rays and calculate, how they reflect and bounce around throughout the scene. And so instead of that, what normal games usually use is, I guess it's not exactly like I guess PBR would be something else, but it's using like rasterized graphics where you just say, okay, there's a triangle here and there's a light over here. So like this is what the color should look like on the triangle. And then you do that for all of the different meshes in your scene. And that's like much more computationally efficient versus ray tracing. Although it doesn't look quite as good as ray tracing. Although you can use all these complicated tricks to make it look better and better and better, which is a lot of what graphics programming is. Because like a ray
Yeah.
tracing engine is like pretty simple in principle.
Yeah.
Um,
What do you think about the current state of graphics programming and where the industry is heading? Because I see a lot of back and forth about like some very computationally intensive methods like ray tracing kind of being pushed to the forefront and
yeah,
things like DLSS that people are kind of pushing back against.
right. Yeah, so I mean, I've never worked in the industry, but what I can say is like I feel like at some point you reach a limit of how good the graphics can look. Like if you imagine back in like the graphics today don't look that much different. If you imagine you're playing like Call of Duty or something, like the graphics in the newest Call of Duty game don't they're not that much different than the one like 5 or 6 years ago, right? But like maybe in 2012 or 2015, like there was a huge improvement in graphics. Um, but I think at some point you like reach a limit where the scene looks realistic enough that your eyes can't really tell a difference, even if it was like more physically accurate. And also like, you know, it's also you can also make it look better by like increasing the texture resolutions and the lighting map resolutions and stuff. But at some point still like you reach a point where your eyes can't tell the difference whether it's like a 4K or a 2K texture. Um, so I think at some point it kind of levels off in terms of like what's how much are you gaining by adding a bunch more computing power? That being said, I don't know if there's going to be some interesting things with like using kind of like the diffusion models or something to like take a video game graphics and make it look like a video, like a real video or something like that. Because you can still tell it's not real if it's a video game. So I don't know if like something like that could be, um, if they could have something like that in the future that's like makes graphics that basically look like a video camera or something. Um, but yeah, in terms of like continual improvement in graphics, I mean, the one thing that is kind of interesting is like, these global lighting approximations and stuff where you can, get like better bounces off of, simulate like light bouncing multiple times in a scene without doing ray tracing and stuff like that. Um, but yeah, in terms of like graphics, I don't know. My sense is that we're nearing a limit where there's diminishing returns from continual improvement in graphics. That's my sense, but I'm not really like an expert in the industry at all. So
Yeah. I mean, that's kind of what I think too. Like when you were initially describing it, I was like basically diminishing returns.
right.
I think about like Battlefield 4,
Mhm.
which was like 10 or 12 years ago or like a long time ago. And I feel like nowadays most FPS games still kind of look like that. Like it's the
Yeah,
same level of
exactly.
fidelity.
Right.
I have, oh, were you gonna say something?
No, no, sorry. Go
Oh,
ahead.
sorry. Yeah, I was just gonna say like I've also seen people comment on like the centralization of AAA studios or
Mhm.
game studios that previously used to like roll their own engines or use like
Right,
long-standing in-house engines, like
right.
moving more towards using like Unreal Engine.
Mhm.
And I know a lot of people have problems with like Unreal Engine's rendering pipeline, and they say that
Right.
like this is like basically just pushing towards diminishing returns, and like
Yeah.
these studios should be not using Unreal because it's forcing them kind of into that pattern. Do you have any thoughts
Yeah,
on
yeah.
that?
Yeah, totally. I feel like with, using engines, and this is part of the reason why I want to make my own engine is that like it kind of forces your all the games to look kind of similar. Like with Unreal, especially, you can all of the games made with Unreal Engine kind of look similar in a way. It's like they have a similar vibe to them, I guess. And I guess it's kind of similar with Unity too, um but yeah, it does kind of push you towards like a certain style, I guess, and like what's easiest to make with the engine is what you end up kind of making, right? And so it ends up, making everything the same. And also, yeah, like you're also giving a lot of kind of power to like these companies that could just like change the terms of use for these engines, and then all
Kind
of
of
your
like Unity.
depends on it. Yeah, like Unity did. Because you get so locked in if you're, like it's so hard to switch engines if you just wrote a whole game using a certain engine. Like you can't just switch it that easily, right? You'd have to like rewrite a ton of code. So there's a risk, like a business risk of getting kind of locked in, and then you don't know if they're going to change their terms sometime in the future to something that's not as attractive as it is right now. Um, so I like the idea of making your own engine. But yeah, and I think hopefully more people do that in the future.
Looks like Wyatt said some older games have better graphics than newer games, which I think is an interesting point. I think there's a big disconnect between like graphics can mean either like style or fidelity. You know what I
Mm,
mean? Like there's really old
yeah.
games that look really good stylistically, but they're not like high fidelity.
Yeah, exactly. And there's another issue which I know a lot of people complain about is that like performance. Like it's easy to make like a really nice looking game, but then it doesn't run very well on a lot of people's computers. Whereas like if you write your own engine, you can really optimize it for exactly what you're doing and just remove all the extra stuff that you don't need.
Yeah. So I guess for you, I mean, it seems like maybe part of the reason that you've been working on your own engine is because it's fun and also because it
Mhm.
gives you more control. But what do you think like the biggest benefits have been for you? And do you think that there's anybody who should consider like not writing their own engine for certain
Yeah.
reasons?
So, I mean, I would say, um, in terms of, yeah, like number one, it's fun I find it fun, but maybe that's kind of like a sick form of fun. But it's also like I think, it's not like I mean, it's a lot of work, but if you don't make like an editor or anything, it's not like impossible for a single person to do. And if you don't expand the scope of your engine to be like general use case or so, like you imagine like Unreal, it's a general purpose engine. Like if you just make your engine with like, you could make it general purpose in the future, but it's really like if you don't need a certain feature, just like don't include it, kind of thing. Then it's a little bit more feasible for somebody to actually write an engine like by themselves, or with like one or two people. Um, but uh, but yeah, in terms of like, yeah, whether other people should do it, I don't know. It depends on like whether, you're really into if you want to do it, definitely. But um it depends. Like I would say if you're like making a bigger game, maybe it makes more sense to do. Another benefit of it is like once you make the engine, you can just like tune the pipeline of like adding features to be extremely efficient. So like, like me and the other guy I'm working with can like crank out new features in like a day or something, because we just know like exactly what you need to do, and any bugs, it's like the whole thing works. You can easily figure it out, and you don't spend instead of digging through like documentation of like Unity or something, you can just add the code in yourself, or dig through your code and figure out what the issue is or whatever. So in that sense, it's nice. I would say, yeah, like I don't know if everybody should do it. If you're just doing like a small game, um, and you're kind of just doing it for fun, maybe it doesn't make sense. And a lot of people would say it's not super efficient to write an engine if you just want to make a game. But at the end of the day, you do get like you're building something valuable that like you kind of own at the end of it. So, you know, you you I wouldn't say it's like inefficient to do, necessarily, but I don't know. Yeah, that's my thoughts on it.
Yeah, I would agree with you that it's kind of almost like a masochistic level of fun.
Yeah.
Like I think like the trap that at least I've fallen into, I've been working on kind of like a trivial 2D engine for like 2 years, is like I will be working on something and then I'll identify like another big feature that would be like, oh, this would make it more generic, like a scripting API or like I don't
Yeah,
know, like a new subsystem. And then I just like get stuck in doing that for like months and months, and then it's like on to the next thing. It's like a perpetual
I
cycle
know
of like,
exactly what you mean.
and then you go back to rewrite the old thing, and then now you have to rewrite every other subsystem, and it's just
Yeah,
like it could take like I mean, we've talked to people who have been working on their engines for over a decade. Like
yeah,
Panos, I don't know, you know Panos
yeah.
Karvelas?
I talked to or follow him on X and go back and
Yeah.
forth a few times. Yeah,
He's been working on Spartan for like 12 years or something.
yeah. So I
Yeah.
think for me, I know exactly what you mean about like you can get sucked into a vortex of like, oh, I need to add this and then this. But the way I try to stay focused and not let like the feature creep kind of kick in is to like have an end goal in mind. Like, you know, I'm building this game. It's like you know, a crafting kind of sandbox game. And basically like I'm not going to add anything to the engine unless it's needed, like unless I am adding features to the game and I'm like, oh, I need like, I don't know, like like I need a particle system, you know, so I'll go add that in, and then I'll go back to adding stuff to the game, and then I'll be like, oh, I need like a, I don't know, a ragdoll system, so I'll go and add that in. That way, it kind of constrains the scope, so you can actually finish it in like a
Yeah.
single human lifetime. Because yeah, I could definitely see like if you just wanted to make a game engine with no game in mind, it's almost like there's almost like a never-ending amount of features you could add, right? And so that's I think where like my engine is, I think it's only 40,000. I mean, maybe yeah, it's probably 40,000 lines of C++, which is like not a crazy amount, you know? So I try to only add like what I need. That way, you know, otherwise I don't think I would ever be able to finish it. Um, so yeah, I mean yeah, that's what I think
Yeah.
about
How do
So
you
could you
how do you
Oh, go ahead,
manage your
Greg.
time? Like, because you
good
said you
question.
were pumping out like two whole like mechanics in like a day. How do you do that?
Yeah, yeah. Well, maybe not two in a day, but like sometimes you could do one in a day and get
Okay.
like a not like a super polished version, but um so actually yeah, I was thinking about this because I figured you guys would ask me that. But so like I also work full time, which so I just do this like kind of like at night in the morning. Um but basically what I do is like I feel like I usually think about like, all right, I want to add like I just added like a archery or like my friend added it and then I basically took it and like cleaned it up. But basically, like the way I kind of try to do it as efficiently as possible is to think like throughout the day, just be like, okay, I'm going to add this. And then I'm like, okay, to do this, I need to do X, then I need to do Y, and then I need to do Z, and then blah, blah, blah. And so I'll go and I'll kind of plan it out and then I'll just go and like when I have like a few hours at the end of the day, I'll just try to like grind out everything I planned out earlier in the day. Um, and you know, like I said, when you have your own like engine and everything, you know exactly how everything works. It's a lot easier to like plan out like super precisely exactly what you need to do to get it to work. The other thing I've been using a lot lately is like I use like Cursor to write code, and sometimes it can just write like you can have it write small section like I'm trying to figure out if you can actually use like the AI tools to for it to be useful for game development. Um, but I found that like you can use Cursor. Like, are you guys familiar with Cursor, like agent mode or whatever, where
Yeah.
it'll like write? Yeah, yeah. So I'll like I kind of have a sense of what it's able to do and versus what it's not. So like for small kind of subsystems that are independent of anything else, you can actually get it to write those pretty accurately. So like for this for this like bow and arrow thing I just added, there's like a crosshair that like changes size. Like, you know, when you like pull it back, it gets smaller. Um, that whole thing pretty much is written by AI. Like I just said, write a crosshair, and then it probably wrote like 200 lines of code, and then I just like tweaked a couple things, and it was good to go. Um, so you definitely, as much as you can use AI, I think that if you're a single person trying to get a whole game done, you gotta anything that you can gain efficiency with, you should definitely use. So I try to use that as much as possible too, but only for like really simple stuff. Otherwise, if you let it go, if you let it go wild on your whole code base, you're gonna have a problem.
Yeah. That's kind of been my experience too, is you get a sense for what it can and can't do. Like I've never really touched Cursor, but I mostly use Copilot like within Visual Studio Code.
Right.
And there's some things where it's like, I don't know, like using it as like a more intelligent like autofill or like really like low stakes tasks like a crosshair or stuff like that. It's super good. But there have been times when I'm like, try and do this and it just completely falls on its face.
Oh, totally. Yeah, and I found that like Cursor is a bit better than Copilot in terms because I used to use Copilot and then I tried Cursor and I was like, oh, this is better. Um, but yeah, in terms of like it has limited use cases for sure. The autocomplete definitely is useful, but I find myself turning it off kind of often nowadays.
Really.
Uh, 'Cause sometimes it just keeps suggesting the wrong thing and it gets kind of annoying. But like the agent mode or whatever, I don't know if Copilot has that, but it'll like go and just write a whole file and then it'll go through your code base and change a bunch of stuff. Um, that thing is pretty crazy actually. Um,
Yeah.
but I'm scared. I'm a little bit scared to like let it go ham on my code base.
Unleash it.
Yeah, yeah.
Yeah. It wouldn't surprise me if Copilot had that because I think they're basically Microsoft is just kind of ripping everything that Cursor
Yeah.
adds.
Yeah, I
But I
know.
think like um does Cursor only let you use like Claude? Is that like the main foundational
No,
model
you
that they
can
use?
switch to different models. I think Claude is the best one though, just from what I've like, no, I think I messed around a long time ago. I usually just use I think defaults to Claude. That one's pretty good.
Yeah. Yeah, they let you switch in Copilot too in Visual Studio. And I think I've also found that Claude is super good. Sometimes
Yeah.
they rotate in new models. Like I've seen like some Gemini ones. They had DeepSeek at one point when the
Oh,
hype
really?
was like all the way up.
Yeah. Yeah. I mean, if you can, anything that makes you more productive, I think is worth doing. Like I also get for like texturing, I just bought like Substance Painter. I mean, I couldn't imagine doing anything without Substance Painter if you're doing like PBR graphics. Um, but other than that, I just use like Blender, for 3D modeling and stuff. Um,
Yeah.
yeah.
For me, I've also found like even more than just like writing the code, like background research, AI has been super helpful for
Oh
me.
yeah.
Especially like when I first started with my engine, like I didn't
Mhm.
know any like basically anything. Like what I didn't know how to program in C or C++, like my engine is written in C and I had basically no experience. So I was like just asking like ChatGPT like can you explain this principle and like I want to solve this problem, how would you do it? And just like kind of like iterating and learning like new ideas and concepts is super helpful.
Yeah. Yeah. I feel like it's cool. Yeah, it's definitely useful for that too. I feel like I know C++ pretty well at this point, but it would have been useful because when I was learning it, they didn't have AI or it didn't exist at the time. But then it came out like probably just after I basically learned it. Um, but yeah, that would be pretty useful. I find myself like I'll ask Copilot like, oh, how do I do like if I forget how to do something, I'll be like, how do I do this? Or like why does this not work? And then it'll fix it for me, which is kind of nice.
Yeah. So we kind of touched on a little bit the game and the engine that you're working on, but maybe just could you like reiterate like from the beginning like what is the game that you're working on? It's survival crafting. How has it progressed along with the engine?
Yeah, so the game I'm working on, it's kind of like it's a lot like Valheim or is it Valheim? I don't know how to say it.
Valheim, I think, yeah.
Valheim, yeah, yeah. So it's kind of like Valheim. So I really liked that game. Like a lot, when I played it first, and I was like, damn, I want to make a game kind of like this one, but then add in some stuff that I wish was in Valheim. Like, for example, so my game, it's like crafting, but you kind of go around the world just like in Valheim, but then you can also like mine underground, unlike in Valheim, where it's like a height map terrain. And so I'm trying to like expand out the crafting system. So basically, like you can mine underground, you can mine for resources, but then you can also build like machines and stuff that increase your or allow you to like craft more and more like at an exponentially increasing rate. Because I also think that there's something fun about like exponential growth, whether it's in like a game. I just feel like that concept in general in some games just like are only about exponential growth, like those little iPhone like tapping. I don't even know what the game where you like collect a bunch of eggs and then you get more and more. You have like, and some kind of like egg farm or something. But basically, a lot of games will like just take exponential growth and like that's the whole game. And so I wanted to add a little bit of that to like the idea of Valheim. And the other thing that isn't in this game is that we're gonna have like it's more focused on like defending your base rather than going around and exploring as much. um, but yeah, so that kind of is the game. We haven't really locked in a name and Steam page yet because it's still kind of early on, but pretty soon we'll have that, and then I'll have more to say about it. Probably should have done that
Yeah,
before. Oh,
that's
well.
awesome.
Yeah.
Yeah, I'll put if you want to send me some links to anything about the game
Uh,
or like your pages or your profiles, I'll put them in the description.
yeah. I'll
Um,
send you my link to right now. I'm basically just posting on X because it's still pretty early stage, I would say. Let's see. Yeah, here's my X account if anybody's curious. Um, but yeah, so that's the game basically. And then I started writing the engine. I started writing the engine a while ago, and I didn't really know exactly what I was going to do for a game. But I decided like I was like, what would be a game that I would buy? And I kind of came up with like a game like this, kind of like Valheim. Um, because I know like a lot of people, a lot of like the conventional wisdom on like Reddit and stuff, on like the GameDev Reddit, is that you should only make a game that's like has a really small scope and you should just ship it. But I feel like I buy mine, that's kind of wrong because like if you want people to play your game, you're basically competing against every other game that's out there, including like triple A's. So if you just make like a really kind of like small game that doesn't have a lot, then you're like you I feel like not that many people are going to want to play it because why would you play that over like a really nice game that you're kind of competing with? So I feel like it's kind of like for me it makes sense to try to tackle like a more ambitious game, even if it takes longer to finish. But that's kind of my sense on that. um,
yeah. People also say like I've seen people say like don't make your dream game.
yeah, yeah.
But I mean, it sounds like this is like maybe your dream game in a way, like a
Yeah.
game that you said that you would want to play.
Yeah. I mean, because I was like, why even make it if it's not like, if you're gonna spend all this time on it, you might as well make something pretty
I agree.
cool.
How do
Um,
you oh, you can continue, sorry.
oh no, good.
How do you differentiate like your survival game from the others? Because I see a new survival game pop up on Steam
But
every week. That's why I ask.
yeah. So I mean, I guess it's definitely in the survival game genre. It's less about like survival. It's almost like a mix between a survival game and like a factory building game. So
Oh,
like as you survive, I added these like steam, like as you
yeah,
progress
I
in
saw
the
your
game.
Steam pipes looked
Yeah.
really cool.
You get like steam power, which allows you to get more and more weapons. And then one thing that we're gonna add, or we like have a prototype version, is we're adding like these gnomes that you can find throughout the world, and they like join your base, and then you kind of can like arm them with you know, your weapon factory basically, and then that allows you to like defend yourself from like waves of enemies basically. And then you have to progress through the world, like you have to go deeper into the world to find like more advanced materials like explosives and stuff like that. So it's a little bit different than like a regular survival crafting game where you're just like alone basically. And yeah, I don't know if that answers your
Yeah.
question.
I think
Yeah.
it sounds
Yeah.
really cool. What you said about the gnomes reminds me of this uh kind of like automation game called Atrio.
Mhm.
And it's kind of like Factorio, but you have to like go out and like collect animals that become part of the factory,
Oh yeah.
which is kind of like an interesting
Uh,
idea. But like, have you been inspired by any other
yeah.
automation games like Factorio,
Yeah, so
Satisfactory, stuff like that?
I played Satisfactory a lot. But one game that I was like, I used to be obsessed with this game is Dwarf Fortress. I don't know if you guys ever play that. It's
Yeah,
kind of insane. Like I used to play it a lot, like 10 years ago, and it was like all ASCII characters.
yeah,
Uh, but like a lot, it does draw a little bit from that game in terms of like um you know like Dwarf Fortress, you have like you have like dwarves joining your base, and you don't really explore outside of the region of your like fortress. I don't know if you guys have ever played it, but um the whole game is about like building up a bigger and bigger fortress of dwarves, and then you have like mining and industry where you like build weapons and stuff, and then you kind of the game doesn't really have a point, I guess, but you get like raided by goblins and stuff like that, and you get sieges. Um, and I really like that mechanic. So I kind of am trying to make it's definitely draws some inspiration from that game. And then also like the look of it is kind of, I don't know, looks kind of like Valheim, um, in terms of like, I don't know, just like the way that everything kind of looks and the overall vibe of it, if that makes sense. Um,
yeah.
yeah. It's
Do
still
you
early,
think?
but yeah, sorry, go ahead.
Yeah. Do you think like what's your end goal with it? Like, do you think that this is something that you would want to segue into like a day job if it was
Yeah, yeah,
possible?
I mean, definitely. Like I like yeah, ideally start a game studio if this thing looks like it's going to be successful.
Yeah.
It gets a little bit more further along, but yeah, it would be cool to have a game studio or something. Um and Yeah, I mean that's the idea. That's part of the reason why that's another reason why I made this engine is because then it's like the whole thing is just like a lot of like game studios will make their own engine, and it's like you just own the whole pipeline, which is a good, I think, strategy. So that's my plan, hopefully, if it all works out.
Yeah. I think you have good odds. I think the game is like sounds really cool. Like it sounds
Yeah,
like
yeah.
something that
Thank you.
I would enjoy. Like it's building connections to all these other automation survival
Right.
games that I've played.
Yeah, like it's
Um,
definitely a game I would like to play. So I was like, if I would like it, then I'm sure other people would.
yeah.
Yeah, I feel
Dan,
like,
did you have a
oh, sorry,
Oh,
go
go
Uh,
ahead,
ahead.
sorry.
yeah, so actually, we didn't talk a lot about your professional career.
Yeah,
I
yeah.
actually want because I wanted to ask. I know you mentioned you haven't worked in the game industry,
Right.
but where have you worked
Yeah, yeah.
before?
So basically, right now I work at a company that we're built like I'm basically doing like optical engineering slash electrical engineering. And so what we're doing is we're basically trying to detect like methane leaks in oil fields using lasers. And so like the technology that this company that I work for um, that we have is basically like we have this laser that we like put into an oil field on a tower, and we like shoot the laser beam out like a couple kilometers and like reflect it back. And then based on how much the light gets absorbed, you can tell whether there's methane passing through the laser beam. And then using that, you can kind of figure out like where methane leaks in an oil field were. And so I basically work on that system now.
Yeah, that's pretty interesting. So, do you get since you? I imagine you got hired from your mechanical
Yeah,
engineering part. So, are you?
yeah.
I imagine you're more on the hardware side, no?
Yeah, so like I did my PhD, and like basically my PhD was focused on building these like low cost laser sensors.
Oh, interesting.
So it's almost like a pretty close analog to my PhD. And I published like a few papers on that. But it's basically like I basically took these laser, and like I spent a lot of time in grad school. And before that I had some other jobs doing like regular mechanical engineering stuff. And But yeah, in grad school I worked on, building these like taking this laser sensor technology. It's called tunable diode laser absorption spectroscopy. And
Okay.
and basically taking this technology and then using basically an FPGA and like some fancy algorithms that I came up with, we were able to make like a really cheap relative, like much cheaper version of this laser sensor that also could like collect data from the laser and then output the like gas temperature and like the gas concentration of like water or H2O or CO2 or something within like 1 millisecond of measuring the laser signal, if that makes sense. And so we use that to like we strapped it to like an engine and did try to do some like control or that's something we want to do in the future with it. But we tried to like take the laser sensor and use it to control an engine in a loop. Um, but yeah, one thing I'll say about that is I feel like you can gain a lot by like taking ideas from one field. So like in my case, I kind of like was just interested in computer science, and so I took like some of these algorithms that like most mechanical engineering people like don't know about and applied it to this like laser sensor technology. And that was like a novel thing that nobody had tried before. So anytime you're like, I feel like you can get a lot by taking things from one field and bringing them to another field, just as a general idea.
Yeah, it's pretty interesting because I wanted to ask, was there like a day or like a moment that you had that you were like, you know, this mechanical engineering stuff, it's all fun and games, but I'm gonna go over to the game dev now.
Yeah, yeah.
You know,
Yeah,
because
I mean,
like it's because it's so cool because what you're talking about sounds so interesting and
yeah.
you sound like you're very interested in it. That's why you
I mean,
probably got a
I
PhD in
like
it.
I like that too. I'm the type of person who likes to do like a bunch of different things. And I
Yeah,
feel like it actually helps, like I was just saying, like with being able to draw ideas from different
yeah,
fields together, you can do like really interesting stuff. And so I've been doing like the game development stuff and this like in parallel, if that makes sense. And I like to have like I like to be able to switch from like if I get tired of doing laser engineering stuff, then I can
yeah.
switch to something completely different. I feel like it kind of helps you to be able to do more things because you don't really get burnt out as easily. You know what I mean?
Yeah, actually, I have the same. I do the same thing. Go to work or work on some
Mhm.
crazy software, and then come
Yeah.
home like, you know, something else. Just like you said, I do it because of burnout. I
Right,
just
right.
yeah, exactly that. I think
Almost like an exploit to like not get burnt
yeah,
out and do a shit ton of work.
yeah, I know, right? Because it's like I sit at a desk for 8 hours a day at my day job, and then come home. Well, guess I'm sitting at my desk again. Well,
Yeah, I
what am
know,
I going to
right?
do now?
Yep.
So
Yeah, just
so yeah, so relatable.
I know, right? It's like, yeah, I just feel like I have to be doing multiple things at the same time. Otherwise, I get bored or something. I don't know. Maybe I have ADHD or something like
Maybe
that.
we all do. I feel like I'm the same
Yeah.
way. Like
Me
what Dan
too.
said, where it's like go to work for 8 hours and then come home and then I would get back on the computer
Yeah.
and write code for
Yeah.
like 4 hours.
I know, right? That's what I do too. And I'm like, how am I even doing it? But I think there's something about the fact that it's two different things where it doesn't feel like somehow in your brain it feels like you're doing different work or something. I don't know what it is,
Yeah.
but
It's like do what you love and you'll never work a day in your life.
yeah, exactly.
Yeah, for me, it's a lot of the motivation aspect to it. Found because you're motivated to do this one part, but you work on it for a certain amount of time, and it's like, okay, let me take a break.
I know,
You
right?
know?
Yeah, it's
Yeah,
like you got to switch it up every once in a while.
yeah, of course. Yeah, because I think it's so interesting that you think, yeah, well, you eventually would like to get a game development studio,
Uh,
or at least make your own thing
yeah,
if your a game ends up doing well, which I hope it
yeah,
does.
yeah,
Uh,
yeah.
but yeah, I know. Super cool goals, and I hope it works out for you.
Yeah. Yeah, same.
Yeah. I
If
actually
not,
kind of
I'll
had
just
some
try something else though.
I had some questions for you, like
Huh?
to that end, about grad school and your
Mhm.
experience doing a PhD. Kind of like when did you decide that that was for you, and what was
Yeah.
the experience like?
Yeah, so like so when I was an undergrad, I like I said, that with that senior design project that I was talking about earlier, you have to, we worked with this company building basically laser sensors, but it was a completely different company than the one I'm working for now. Um, but I had no interest in going to grad school. I was like, I want to go work. And I did this project and it was pretty successful. Like we built this really kind of novel laser sensor using, we basically took like like a fiber optic cable, and then you could measure the length of it really precisely with a laser, like down to like nanometers. And then when it heated up, you could detect whether it changed length because of like thermal expansion. And but anyway, so we did that, and then this other professor at University of Colorado, who ended up being my PhD advisor, like was like, "Oh, do you want to, join our group?" It sounded like this was pretty successful. So, and I was like, "I don't know, I need to think about it." And then ultimately, I was like, this sounds like a pretty cool experience to go do a PhD, and then you get to go to like conferences and stuff like that. You get to do research, and like it was awesome. Like I love doing it. Another thing with like, and then I was like, I don't know, I don't want to like pay for it, but apparently when you do a PhD in engineering, it's free, or you get paid a stipend to do it. So I was like, okay, I can delay getting a job for 5 years, and then I can, go do research. I was like, I'm down. So and it was great. I loved getting my PhD. I mean, there's definitely a moment like halfway through when you're like, damn, this sucks. But once you get through that, it's not bad.
Yeah.
You know?
Yeah, it's honestly it's actually really inspiring for me to hear you still say like even after you've done a PhD, you're working in the industry and you're still like, yeah, I would start like a game development studio.
Yeah, yeah.
Because one of the things for me is like I'm looking at grad school right now, specifically doing a PhD in security, like computer science, computer
Oh yeah.
security. And I was kind of like for a little bit, I was like, well, if I do this, then this is it. You know what I mean? I was like, it's just this, and then it'll be nothing else. And then I thought about it, and I was like, well, I can do a PhD and then just do whatever I want after.
Yeah,
Like, just
exactly.
do it for the virtue of like it's
Right.
fun.
Yeah, it is fun. And like you meet a bunch of people, and like I don't know, like a lot of the PhD stuff that you end up doing, like the research is so focused on one specific thing that it's unlikely that there's going to be a job that like is the exact same thing. Although actually in my case I ended up finding that, but most people don't. So
Yeah,
but really like it just shows when you do it, like if you want to go get a job after, basically do whatever you want, it just shows that like you're basically able to kind of get stuff done, and people like that, and that you're able to like, it really, what it really helps with actually, that I would say the main thing that getting a PhD helps with is like public speaking, and like doing doing talks. Like I had to do so many talks, and like going to conferences and presenting to people like that. If you have any fear of doing that, it just gets like beaten out of you basically. And then and then also writing, so you end up having to write quite a bit, so it improves like your writing skills and being able to like take an idea and distill it down to the minimum number of words, and the most concise way of saying something, and like the most, I don't know, it helps improve your writing skills a lot, I would say. And those are probably the things that actually get carried over the most to like whatever you do next. So I would recommend doing it. I mean, especially since, I mean, if you can get a, I don't know how it is with computer science, if it's like basically free to do, or like if you get a stipend and stuff, because then it's like, why not? uh,
yeah. Yeah, that's what I realized too, was somebody told me like if you're paying for grad school, you're doing it wrong. Like
yeah,
they
yeah.
were mostly saying that about a master's, which some people do pay for a master's, but
Uh,
ideally you shouldn't. But definitely a PhD in computer science is, I feel like it's very rare for somebody to pay for that themselves.
yeah, totally. Um, yeah, no, like, yeah, that's the thing. If you don't have to pay for it, it's like, and it pays you, you usually get a stipend or something. And so if
Yeah.
you can basically just live for free, it's like pretty fun actually.
Yeah. I did hear my manager at my job right now, I work part-time in research. He did his PhD in computer science at Dartmouth, and he was telling me like, look, like the main thing is like don't go get a job in industry and then go do the PhD because you're
Yeah,
gonna
yeah,
get used to having money and then you're
right.
not gonna have as much money.
Exactly right. Yeah, you're gonna be, if you're gonna do it, you should just do it right off the bat. That was one thing I almost did, was that like when my PhD advisor was like, "Oh, you should join our group," I was like, "I don't know. I kind of want to like work a little bit and save up some money." But I think that's not the right move. Yeah, because you get used to like having more money, and then it's kind of hard to be in like grad school. The one other thing I'll say, like, my PhD advisor was like really good. Like I thought he just is like a really good mentor and stuff. Um, but I've heard that like from other people, like I would just make sure you find like a good advisor, if you're gonna do it. I'd say that's probably more important than the actual like research that you're doing specifically. Um, because yeah, having a good advisor and good mentor helps a ton. Um, and yeah, because it is a bit of a grind. Like I was saying, halfway through, you're like, man, I don't know, just can't see this thing ever finishing.
Yeah.
You know,
Yeah. So I have like kind of a handful of questions about like, not specifically the PhD, but kind of like the experience when you're in it. Mostly like stuff like commitment and like hard work and problem solving. So one of
yeah,
them
yeah.
was like when you're presented with kind of like an impossible problem or like a very difficult problem, how do you go about tackling it? Like, what is your methodology?
Yeah, so I mean, I take some inspiration from computer science algorithms. So there's like two ways you can solve some of these like really hard problems. I feel like, or there's two types of like R&D/engineering. One is like you're kind of doing like gradient descent, where like you're taking something that already exists and you're just like improving it in like an obvious way, sort of. Do you know what I'm talking about? Do you know like
Yeah.
gradient? Um, and then the other one, which is like works when the problem is extremely hard, is just like brute force search, where you just have to try everything until you get it to work. Um, and so that's like, those are basically the only two ways to do it. So for me, like I was trying to figure out how do I do this, like basically, oops, sorry. I was like, how do I solve this problem of like making this cheaper laser sensor when like nobody's done it before? And how do I like make this fitting algorithm work faster? And I was basically just trying different things over and over again and thinking about in my head, like, would this work? Would this work? And then eventually, like after like 6 months, I came up with this algorithm that worked really well. Um, and that ended up being like the basis of my PhD pretty much. So yeah, I would say like, yeah, in terms of solving really hard problems, sometimes the only way to do it is through brute force. Whereas other times, if it's like a gradient descent kind of thing where it's like a pretty clear path to improvement, then usually it's like a lot of that low hanging fruit has already been picked, which is in terms of like when you're in grad school and you're trying to do something novel. Um, so that doesn't always end up with like something really new. So yeah, I don't know if that answers your question. It's
It
not the
does.
best.
Yeah.
Try
Yeah.
everything until it works.
It's really interesting because I have identified those two before, but I've never actually heard anybody else say that because it
Yeah,
really
yeah.
is like you have two options. One is just like bang your head against the wall until
Right.
eventually you stumble on something that works and then
Yeah,
you
yeah.
figure out why and how.
Uh,
Or you can kind of like for some problems you can sit there and read textbooks and forums and like intuit your way down to the
yeah,
optimal solution. But
exactly. Kind of like Edison or something. Like what didn't Thomas Edison when he invented the light bulb, he had to try like a million different materials.
yeah.
Like it's kind of like that, you know?
Yeah, literally.
Yeah.
What about like for motivation? Like sometimes I imagine that motivation to even like throw your head at a problem gets rough sometimes.
Yeah. I mean, I feel like it's hard to say. I think the way I think about it is like say it's some really hard problem that nobody's figured out yet, the way I like think about motivation is by being like, well, it's gonna be hard to figure this out. So like the only way to do it is to just keep just hammering on it until it works, basically. So like if you kind of feel demotivated, I usually just think of it like, all right, well, I'm just gonna keep trying, and I don't really know if I have a good answer for that actually.
Yeah.
Except for
Re-
like if you don't, I usually think like, all right, if I don't do this, like nobody else is gonna do it, kind of thing. Where it's like the only way to do this, or if you think like, okay, if I try enough things, eventually it'll work. So if I'm, spending 5 hours on this problem, like eventually I'll hit the point where it works, even if the next 5 hours seem like nothing got accomplished. Um, so I don't know, that I guess that's kind of how I think about it if I was to put it into words, but it kind of sucks when you're halfway through.
Yeah. Yeah. I've noticed the same thing. Sometimes for me it gets a little rough. Like computer science, like not every problem is like solvable in a
Right.
trivial amount of time. And sometimes there's problems where you can't solve smaller steps. You have to solve the whole thing at
Yeah,
once.
exactly.
Like I was like teaching myself a lot of like physics programming to work on like a 2D physics engine like a couple months ago. And I think there was like a week where I would get on after class and I would spend like 3 or 4 hours straight just trying to debug like one thing. And I did that for like 4 days. And I was like about to give up. And then the last thing I tried randomly was like worked and the entire
Yeah.
thing worked. And it was like at 10% for 5 days. And then it was completely fine like the next
Yeah,
week.
the other thing that kind of reminds me, the other thing I think when I'm like in the trenches of trying to figure something out is like the thrill you get when it finally works is so extreme, especially if you spend so much time like grinding on it. That you just need to think about that at the end. You'd be like, this is gonna be epic when I finally figure this out.
Yeah. Man, there's been times where I am sitting at my computer for hours and then I fix something. I literally have to stand up and
Yeah,
like
yeah, I
walk
know,
around.
right?
Like it really is like one of the best feelings.
Yep. Yeah, that's 100% true. Like I think, yeah, that's what I start to think about too. And I'm like, the more work it takes to figure it out, the more of a thrill you're gonna get at the end when you finally figure it out. So
Yeah.
all levels out in the end.
Yeah. Nice. Well, do you have I guess I'll combo two questions. Like, do you have any advice for us as like mostly computer scientists? I think everyone in this call is a computer scientist. As computer science college students, do you have any advice for us? And then also, do you have any additional advice for those of us who are planning on doing like graduate school or research?
Yeah, yeah. Yeah, in terms of like if you're an undergraduate student, I would just say like if you think about what's valuable about college, it's less about like learning stuff, to be honest with you, because all this information you can find online and stuff. You can teach yourself a lot, but the things you can't get from that are like the people you meet in college, like the guy I'm working with now in this game. I met him in our senior design project. So like you end up working with a lot of people and you figure out like who you work well with. And those are good people to like partner up with in the future. So that's the main advice I guess I would give you guys if you're an undergrad is, make sure you meet as many people as you can and like make the connections while you're there. So I think that's the most important thing. That's the most valuable thing later on. Um, and then yeah, for people thinking about grad school, I would just say like if you're interested in like, I don't know, kind of like research and stuff, or you're interested in like doing new things versus kind of like iterating on older things. I don't know if that's a really good way to say it, but it might be good for you. Again, you'll also meet like a lot of people in graduate school, and like if you, yeah, you're gonna if you want to get better at like writing and speaking in front of people, that's another thing I would recommend doing. And yeah, I mean, I'm kind of reiterating what I said before, but finding like a really good advisor for grad school is probably the most important thing rather than like being perfectly or being interested in the exact subject that it is you're going to be doing. Because like ultimately, once you get into the weeds of any subject, it's probably going to become interesting once you're at the forefront kind of the technology. Um, so yeah, that's the best I could come up with on the spot for grad
Yeah.
school.
Yeah, sorry to put you on the spot. I think it's super
Yeah,
helpful. I mean, yeah. I'll I want to be respectful of your time. I know we're
that's all good. I
5 minutes
mean,
past the
I'm answering
original time,
questions.
but maybe I'll just open it up for anybody else to ask any additional questions. I think I've kind of exhausted everything I had in mind. But does anybody else have any other topics?
Oh, I wanted to ask, how do you like share the work with your teammate? Because you say you're working on this whole game with another person.
Yeah.
How do you like I guess share all the assets, set up the project and stuff like that?
So, like for the code, we just use Git. I don't know how you do it otherwise, but
Yeah.
and then for the assets, I don't really have like a great way of doing it, but basically, since it's only two of us, we just use like Microsoft OneDrive, and basically we have like a folder which is like assets that are completed and like gonna go in the game, and like that, and it's on OneDrive. And then we'll have like asset source, which is like all the Blender files and stuff to produce the like 3D meshes. That's probably not the best way to do it, to be honest. I mean, that just like works, but if you had a bigger team, you need to probably figure out a better way to do it. I actually don't know what the best practice is for asset management. Um, but for me, I'm like, if it works, then might as well just go with it for now.
Yeah. We have been using Git LFS. So we have
Oh,
like a GitHub org that we're all on.
uh,
And then we were initially like actually using GitHub's LFS storage, but they give you like a ridiculously low bandwidth before you have to
oh,
start paying for it. I think it's like 1 GB of storage and 50 gigabytes of download and upload a month. So like if 25 of us download it once and then push a change once that has like assets in it, it's kind of like already exhausted. So we switched to like we have our source code is hosted in the Git repo on GitHub, but the LFS pointers are pointing to a proxy on a server on campus that has just the LFS stuff,
oh, okay, interesting. Yeah, I never
which
do.
is kind of a weird setup, but
Yeah, maybe in the future we'll probably figure out a better way to do it. The one thing with me, I'm like with the game and stuff, I kind of, even if I know something's suboptimal, I'll just keep doing it because going back to like going into a vortex of things to make better. I try to like pick and choose what's like what's going to give me the most efficiency in terms of like using Git, for example, is like that's pretty obviously important, but I usually try to, even if I know something's suboptimal, I'll just keep doing it until it's like becomes a behemoth or something where I'm like, all right, this is actually, I need to fix this. I
yeah.
haven't reached that point yet with the assets, but in the future, I feel like that definitely will happen in the future.
Yeah. I looked at a bunch of different options when I was trying to figure it out for this club. I think like if you're interested in home lab stuff at all, like it's pretty easy to throw up like a Git or like GitLab instance, which all of those like open source Git front ends, like they all have LFS support built in now. But if you're interested in like self-hosting, there's a lot of good solutions.
Oh, so like have your own server kind of thing.
Yeah, yeah,
I was thinking about that, but then I was like, but then I also like being in the cloud because then like if my computer breaks, I'm not totally screwed. Um,
yeah. You could just instead of self-hosting on your server, you could buy like a VPS or something and then self-host there and do like snapshots maybe.
Interesting. Yeah, maybe I'll look into that at some point in the future. But yeah. You guys have any other questions?
That's the end of my questions.
Nobody? All right. All right, well, yeah, it was really awesome talking with you.
Yeah, yeah.
I feel like we touched on a lot of really cool stuff, so I'm super happy about how it ended up.
Yeah,
But
me too.
yeah, it was great talking to you.
Awesome. Yeah, let me know when you guys post the YouTube or whatever, and I'll share it on X.
Sounds good.
All right. We'll talk to you guys later. Thanks.